Hello, space fans. Good morning, and welcome to our live coverage of SpaceX's Transporter-6 rideshare mission, launching 114 satellites into orbit. And we're starting a little bit earlier than normal for a SpaceX launch today because this live stream is actually brought to you by EOSDA, a global provider of AI powered satellite imagery analytics, and they're launching their first of 7 satellites for their EOS SAT constellation as part of this mission. Their constellation, the first agricultural focused satellite constellation among remote sensing companies on this flight, and we're really excited to give you a preview of what that means. And with me today are some members of the EOSDA team. We have Vladimir Verbadal, Chief Product Officer of EOSDA. Vladimir, thank you for having us. And great. And we have Alexander, Krivashin, Senior Researcher of EOSDA, to tell us more about the mission. Gentlemen, thank you both for joining us today.
Hello.
Pleasure.
Well, Vladimir, let's start with you. Tell us about EOS Data Analytics. How does the company use its Earth observation data to help agriculture and farming around the world?
Absolutely. If we can go to the slide number 2, you can see that EOSDA is a US-based company headquartered in Menlo Park, California, with more than 5 offices across Ukraine, more than 200 employees, very strong team of PhD professors, technical specialists. We have almost 1 million users, more than 50 million hectares processed, more than 100 million kilometers of satellite imagery analyzed. We're presented worldwide, almost 200 countries. We have some notable clients like World Bank, GoldenEye, Ryzen, etc. If we move to the next slide, you can see our core strategic product offering. The biggest and the most well-known product is crop monitoring, where we leverage satellite data and do analytics to help customers from agricultural verticals leveraging different use cases there. We also do have some custom solutions where our PhDs, they tailor machine learning algorithms, they build the models, and we're able to offer clients such sophisticated services as harvest monitoring, yield prediction, crop classification, and etc. If we move on to the next slide, you can also see some of other product offerings that are out there. So in product, we leverage satellite data to analyze deforestation use cases, forest health, and some other use cases which are important for forestry verticals. And last but not the least, we have EOS Land Viewer product, which is like all-purpose analytics tool for GIS specialists. So basically, you can do any type of analytics there on the fly.
Well, that's wonderful. And of course, you have EOS SAT-1 on this launch. I should mention, by the way, liftoff of SpaceX's Falcon 9 carrying EOS SAT-1 and the 113 other satellites is at 9:56 a.m. Eastern time. So just at the bottom of the hour as we're talking now. And it's launching from, of course, Cape Canaveral Space Force Station in Florida. And so EOS SAT-1, the last satellite that will be deployed for this mission, kind of the best for last, I would say. Vladimir, what is that, and what role does it play in EOSDA's mission there?
EOS SAT role is just huge for our business and for our analytic capabilities. So we have been coming from the background of product solutions for the customers. We have been a software product company for years, so we do understand the challenges of our clients who come from not only farmers but also big input suppliers, insurance companies, banking, etc. And there were common problems and issues with the existing satellite data and analytics, the problems with some data interpretation, lack of reliable data, some problems that some data could be of a high cost. So this all has brought us to understanding that we need to launch our own constellation and rely on our own source of satellite data. If we move to the next slide, you can basically see the main benefits that EOS SAT constellation is going to give to our business. So again, its ability to do one-day revisit for specific areas of interest of our clients. It's a pretty good spatial resolution. It's 1.5 panchromatic, 3.0 multispectral. Of course, big benefit of having your own satellite data is that you can offer exclusivity to some big customers. For example, like if you have a big customer in Australia, we can exclusively provide the data to that customer and our analytics on top of that. And of course, another goal is to be able to monitor all crop and forestry lands worldwide and have pretty good revisit time for the whole constellation. If we move to the next slide, that's kind of summarizing all the benefits that EOS SAT is going to give to our business. So basically, we have our own satellite, we have receiving stations through which we're going to receive this data to the ground, and then we have, as mentioned, pretty strong team of PhDs, professors, who are able to leverage the data to deliver high quality insights and analytics to our customers.
And building a satellite, I know, must take a long time. And you mentioned you've got offices across the Ukraine, across Ukraine, the U.S., and specialists around the world. I mean, how exciting is it for EOSDA to kind of be at this point where you're ready to launch?
And again, it's a very, very strong anticipation and amazing feelings. Actually, the satellite was built by our sister company, Dragonfly Aerospace. And I want to give big shout out to their team, and they have managed to find some very smart solutions that are good from technical perspective, but also from business perspective. And of course, the Dragonfly team does have all necessary engineers with or all relevant experience. But one thing is to have this as a plan. Like on the map, it could be a straight line, but in reality, there could be forest and hills. So yeah, there were definitely some challenges that Dragonfly team has successfully overcome, and this brought us basically here.
So EOS SAT-1, of course, is the first of a 7-satellite constellation. How is this constellation for Earth observation different from other contenders, other players in the market when it comes to servicing, like agriculture-focused products?
Right. If we go to the slide 9, yeah, you can see the main characteristics of our constellation. So overall, it's a 178 kilogram mass, which puts it in the mini-sat category. It's going to be orbiting sun-synchronous orbit with a design lifetime of 5 to 7 years. Again, this resolution we already touched on, 1.5 panchromatic. If you can look at the number of spectral bands, it's pretty important. Just to simplify, the more bands you have, the more analytics you can do, and the more value you can deliver to your customers. If we move to the next slide, you can see some key differences between our minisat and the CubeSats, which are pretty common in the space market. So as you can see, our satellite is quite much bigger than the CubeSats. CubeSats are usually 1 to 10 kilogram in mass. And there are two technical parameters which are very complicated, but in practical terms, they turn into big differences in data quality. Number one is point and control accuracy, is actually ability of satellite to point at some object which you want to capture. Let's say you want to capture Eiffel Tower. In reality, there is always some kind of error when satellite tries to acquire it. So you may get imagery of a building next to Eiffel Tower. So for minisats, it's much bigger chance to actually acquire this specific area that you're interested in. And the second one, again, it's point instability. It's actually the possibility of satellite to point specifically at one object and not move, basically avoid any vibration. Again, it's since our satellite is bigger, it has stronger systems for managing that. It's much more likely chance to get actually sharp imagery, where in CubeSat situation, there could be risks of blurry imagery. And the last, if we move to the next slide, the following is quite different as well. Because again, we were always a software product company, so we did understand. We do have big clients. We understand their needs. We understand what kind of analytics they may want to get, and by understanding that, we came to understand what exact satellite do we want to build, and then we built that satellite. where like most of the companies in the market, they're like hardware background companies. They have a lot of experience in building satellites. So they build satellites, they start gathering some data, and then they kind of start thinking, okay, what can I do with this data? What actually is needed by the market? What analytics can I do? So this is also quite different approach. And if we move to the next slide, you can see just overall summary comparison of our data versus competitors. So if we look at some of the competitors, which is Sentinel-2 and Landsat-8, those are kind of free sources of satellite data, which is launched by ESA, etc. So there, our big advantage is spatial resolution. So we have 3 meters versus 10 and 30. So this allows us basically to do analytics of very small fields and be able to serve our clients better. If we compare it to some of the commercial competitors like Planet, SuperDove, Axel Space satellites, so they have relatively okay spatial resolution, but they have less bands. And again, as mentioned in one of previous slides, the more bands you have, the more types of analytics you can do. So us having more bands there allows us to be superior in terms of analytic capabilities than our commercial competitors.
And once EOS SAT-1 is in orbit, how long? How are you going to track the satellite and I guess the full constellation itself over time? And how long will it take to start getting that first science that you mentioned there?
That's a great question. Actually, as you can see here, I mean, we're launching. I mean, there were some reschedules of the launch, so you can see the launch date is a bit outdated here. But in principle, our first, I would say, 2-3 months are going to be dedicated to commissioning period, where basically we do test all of the systems of the satellite, make sure like power system is working, make sure memory is working, etc. And then we do calibration validation campaign. So we're kind of making sure that our satellite data is then processed and calibrated in a proper way. And we expect that by April, May, our satellite will be ready for like commercial volumes data retrieval. We're going to be able to start developing our science use cases and start implementation to our product portfolio.
Great. So still a few more months then for that first science, but less than half an hour for launch itself. Let's talk about that science there. Alexander, how does EOS SAT-1 observe the Earth's agricultural sites, and what tools does it use to do that?
Oh, thanks for the question. First of all, the EOS SAT-1 will provide the high resolution data, and based on this data, we'll create and develop different products, and these products will be available at our crop monitoring platform. And basically, we use satellite data in different ways. For instance, simple way is just to manipulate with different spectral bands in order to create and generate productivity index, leaf area index, normalize different vegetation index, and many more vegetation indices. And of course, the high spatial resolution of new satellite will improve the accuracy, the quality of these indices. Another way of using satellite data is in different process-based models. For example, we can assimilate leaf area index in biophysical model and significantly improve the biomass estimation. Another way, and maybe most popular, of using satellite data is just use as predictors in different machine learning and deep learning methods. So, and this will really improve the accuracy of our crop classification and yield prediction. And if you move to the next slide, based on the wide spectral range, so all available vegetation indices at the moment can be restored from the new satellite data. And besides, also the new indices will be available. For example, irrigation index, which will show the difference between total water consumption and total water requirements of the plant. Based on this index, farmers can observe if there is some water limited condition in their fields or not. So very useful information.
And the extreme resolution for EOS SAT-1 with its optical and the spectral bands compared to other satellites, how does that kind of help, I guess, bring kind of more data to the table for your customers, for your folks that are that maybe were using other data prior, but now you'll have this new tool set for them?
I think the main benefit of our EOS SAT constellation is this constellation will be agro-focused, and there are three basic points which may make this constellation agro-focused: the spectral, spatial, and temporal resolution. The spectral resolution, as Vladimir already said, the 3 meters with the possibility of reducing up to 1.5 meter. And of course, so high spatial resolution is very favorable to accurate determination of any biophysical parameters. And the spectral resolution is the same as Sentinel-2 with certain bands in spectral, near-infrared, and shortwave infrared part of the spectrum. So it's like a Sentinel, but with a higher spatial resolution. And of course, the revisit time. The revisit time after launch, the whole constellation will be 1-3 days, which will fill the gap in temporal resolution. This is very good because it's almost provide the crop monitoring continuously. It's allow us to provide crop monitoring continuously. So
it sounds like you'll get not only a closer look, but a more often look of your crops and your fields there. And I guess for farmers and for agricultural companies using that data, how can that help them when they're planning out their crop plans or to grow more food or other crops?
First thing, the farmers can save the fertilizer and pesticides use our data. Again, the high spatial resolution of up to 3 meters will help to provide accurate data about different anomalies in the field. For instance, as a rule, the low values of red H chlorophyll index show the low amount of nitrogen in the field. And based on this data, farmers can save the fertilizer by applying only in the anomaly zones. And also, as already mentioned, the key advantage of the new data is that it can be directly used in biophysical models and in statistical models, and in this way, we can estimate the yield in advance, and it allows the farmers have more time to provide prevent measures to avoid food demand crisis.
And actually, to kind of follow up on that, I mean, how can EOS SAT-1 and the full constellation, help not just monitor these crops for your clients, but also just the Earth's food supply overall and the impact of climate change on agriculture when you're looking at so much of the world so often over time?
Yes. The EOS SAT constellation will help to solve different problems concerning to CO2 decreasing. Of course, directly data cannot be used for CO2 emission monitoring, but using the new data, we can accurately estimate the CO2 soil sequestration, depending on different farmer management. And of course, the CO2 soil sequestrations reduce the CO2 concentration, and it directly helps to solve the problem of climate change. And of course, some problems as according to food security, the monitoring on flooded territories, the detection of droughts, the ice melt detection, all these can be accomplished with the new satellite data in the with a more higher accuracy due to high spatial resolution. And also the new data can be combined with existing ones to build long-term time series data. Analyze this long-term series data, we can provide different recommendations to farmers about the potential of their territories, about if their territories or fields can produce 2 harvests per year or not. This is very useful information. All this information can be restored and generated based on new satellite data.
Well, that sounds like a lot of new information that farmers will be able to use. And Vladimir, how will the data that EOS SAT-1 and the constellation will provide be folded into the other analytics products that EOSDA has currently for your customers?
So yeah, basically we're just can look at the one of the earlier slides that I showed, but this one is also perfectly fine. In practical terms, as soon as we have calibrated and validated data coming from the satellite that can be commercial and used to the big volumes, we're gonna be starting the integration of all of EOS SAT data to all of our products. That's crop monitoring, land viewer, forestry monitoring, API products. So as Alexander has mentioned, we're going to be doing some data fusion with like Sentinel-2 and some other sources, giving our end users even more, benefits and possibility to monitor their fields or their farms. And again, this we're going to leverage some custom projects, and our main goal is to meet the demands of our customers coming from like banking, insurance, farming industries, and etc.
Great. And I should just a quick follow up for that one. Have you picked the first part of the world that you're gonna look at, Alexander or Vladimir? Is there
It's going to worldwide. I mean, worldwide, all of forestry and agricultural areas worldwide. So starting from EOS SAT-1, we're gonna try to observe all the world.
Great. So with EOS SAT-1, Vladimir, launching just in less than 10 minutes, it seems. What's next for EOS SAT-2? When will that fly, and when do you hope to have the full constellation complete?
So yeah, as I mentioned before, our full constellation is going to consist of 7 satellites. We're planning to launch 2 more batches of 3 satellites. First batch is going to go in 2024 and the second one in 2025. And with each next batch of satellites launched in orbit, we're going to increase amount of area acquired every day. So with first satellites, we're going to have close to 1 million square kilometers per day. I mean, and with the next batches, we're going to increase this to 4 and then to 7 kilometers of satellite data per day. And obviously, our revisit is going to become better. So when we're going to deploy the full constellation, we expect to have around 3-day revisit time, which is going to, again, allow us to provide more frequent analytics and better meet our customer needs.
Well, that's wonderful. Well, I know that we're a few minutes from what we expect to be SpaceX's start of the final launch coverage. You have a full team of VIPs, in Florida for that launch. And I know that you mentioned, Vladimir, Alexander, that you've got watch parties in your offices there in Ukraine as well. So thank you both for joining us today to talk about EOS SAT-1, its mission, what it's going to be doing with for EOSDA, and the constellation to come. I guess just to kind of wrap up, is there anything else that you'd want to share, either of you, about the mission itself? We've got a couple minutes left until we expect SpaceX to start there.
I mean, I just want to maybe give another shout out to all our partners, to Dragonfly Aerospace Flight Control. It's our sister companies who did a lot of effort in building the satellite, and their expertise was a very, very important part of making the success of the whole project. The team has also developed mission control capabilities, and also big thanks to SpaceX and some of our other partners who is going to support us with downlinking data and pre-processing data. It was a very interesting in the journey, and which is going to continue with some more satellites. But again, big thanks to all our partners and people who made this happen.
Great, and so well thank you both too for joining us today. I've got a couple of stats that I just wanted to let people know about what to look for in the launch to come, because as we mentioned, EOS SAT-1 is the final of 114 satellites that will be deployed on this mission. Liftoff again is at 9:56 a.m. Eastern. If you're just joining us, we're talking about SpaceX's upcoming Transporter-6 rideshare mission and our friends at EOSDA with their EOS SAT-1 mission on it. And this will be at the 15th flight for this Falcon 9 booster. So a lot of flight-proven history carrying your satellite into space there. So, gentlemen, thank you so much, and we'll be watching for that satellite deploy later today.
Thanks,
Thank
Tarek.
you.
Pleasure.
Thank you. Great, and thank you all for joining us. We're going to shift over to SpaceX's live feed in a minute. We are waiting for them to go live from Florida, and as such, thank you so much again for joining us, Space fans. This is the first launch of 2023. Very exciting for SpaceX. They had a record launch period in 2022. They launched 61 missions. That's nearly twice what they launched in 2021, where they launched 31 missions. So, I mean, just one launch shy. And they're looking for an even busier year in 2023. And they're certainly getting off to a strong start with this Transporter-6 rideshare mission. And so I think we're going to go and shift over to that. It's 9:45 now. That's when SpaceX said they were going to start, usually about 10, 15 minutes before their liftoff. And then we can shift over from there.
Looks like my mic was on mute. Hi, Tarek. Hi, everyone. My name is Vanessa Munns. I am the social media editor for space.com. It looks like we are still waiting on SpaceX to begin their live stream. So, Tarek, do you want to ask if we have any questions about this particular launch?
Sure. Yeah. If anyone does have questions for the launch, please let me know. I'm very excited to see how this booster will fly. It's a record-tying 15th flight for the Falcon 9 first stage. It launched, I think, something like 10 different Starlink missions, and then several assorted commercial and NASA science missions or cargo missions too. So it's going to be great to see that, and I would not be surprised if the fairing, the payload nose cone on the rocket itself has flown before too. They've been reusing those as well. And there's a lot of other satellites. We talked about EOS SAT-1 as kind of like the capstone. That is the last satellite that will be deployed on this mission. But there's 113 other payloads also all riding aboard. Lots of scientists and some students, I believe, also too, waiting to see their satellites get into space.
Fantastic. And it looks like they have just started their stream, so we will go ahead and switch over now.
All right, great. Well, keep looking up, and let's see how this first launch from SpaceX does today.
Nice launch check countdown net. Pad is clear.
10, 9, 8.
Launch auto sequence
7,
has started.
6, 5, 4, 3, 2, 1.
Go for launch.
Vehicle is supersonic. Stage separation confirmed. Dragon, separation confirmed. Stage 1 is transonic. Landing legs have deployed. And Falcon 9 has landed.
You are looking at a live view of Falcon 9 set to lift off at 9:56 a.m. Eastern Time from Space Launch Complex 40 at Cape Canaveral Space Force Station in Florida. Happy New Year, everyone, and thank you for tuning in. I'm Shiva, and I'm a space operations engineer here at SpaceX, and I'm joining you from our headquarters in Hawthorne, California. Today, we are launching SpaceX's Transporter-6 mission, and as the name suggests, it's our 6th dedicated small sat rideshare program launch. This mission will mark our first launch of 2023 and our 200th mission of all time. Now, on this flight are 114 spacecraft, including CubeSats, picosats, microsats, and orbital transfer vehicles carrying spacecraft to be deployed at a later time. We'll have a total of 82 deployment events, which will begin around the T+58 minute mark, and they'll last for approximately 30 minutes. Now, we are expecting to lose ground station coverage partway through the deployment sequence, So only some of the deployments will be visible today. However, when we're back in range of those ground stations, we do expect to have telemetry and hear audio confirmation over the nets. Now, if you'd like to see a full list of today's payload deployments, head over to SpaceX.com. With liftoff just about 6 minutes and 20 seconds away from now, let's take a moment to learn more about the Falcon 9 that's on your screen. Now, to give you a sense of scale, this Falcon 9 rocket is standing about 3 meters short of the height of the Taj Mahal in India. It was named after the Millennium Falcon from Star Wars, and it gets that 9 number from the number of Merlin windy engines that are at the base of the rocket.
Stage 1 fuel load is complete.
What you see on your screen are the 4 key parts that make up the rocket. We've got the first and second stages, the black inner stage in between them, and then at the very The first stage is the bottom 2/3 of the vehicle. We refer to it as the booster, and it's got those 9 Merlin engines that do most of the work to get it off the ground and into the thinner parts of the Earth's atmosphere. About 2.5 minutes into the flight, the first stage will separate and make its way back to Earth for a land landing at landing zone 1, which is on your screen. If you're keeping track, today's mission marks the 15th flight for this particular booster. Now, on top of the first stage, we've got that black carbon fiber inner stage. It connects the 2 stages, houses the pneumatic pushers that allow the first and second stage to separate during flight, and also houses the Merlin vacuum engine during ascent. On top of the inner stage, we've got the second stage, which is what's carrying the 114 spacecraft and will take them to their eventual destination in orbit. Shortly after launch, be sure to
Falcon 9
watch
tanks are pressurizing for strong back retract.
Be sure to watch the velocity gauges that'll show up on your screen. You'll see how fast the first stage and second stages are going at separation, and you'll notice that the second stage continues to increase in velocity as we get to orbit. Now, the spacecraft are enclosed in the very top of the rocket in that large nose cone structure, which is called a fairing. Its job is to protect the satellites from the aerodynamic loads until we are out of the Earth's atmosphere, at which point the fairing will separate and expose them to the vacuum of space. You heard some callouts on the net there that we've begun pressurizing the tanks and begun pulling away the strongback. The strongback refers to that truss structure to the left of the vehicle, and we are just about T-minus 4 minutes to go until launch. Currently healthy on the vehicle and the payloads. Propellant loading is almost fully complete on the first and second stages. We've completely loaded fuel on both the first and second stages and are finishing up liquid oxygen loading on both stages. We'll hear a call out around the T-minus 3 minute mark for LOX load complete on the first stage, and a similar call out on the second stage around the T-minus 2 minute mark. Looks like an absolutely beautiful day in Florida. Based on the weather report, we're only tracking a 10% probability of violation. So that means that we are a 90% chance of go weather. But for whatever reason, if we were not to launch today, we do have another opportunity tomorrow at the same time.
Stage 1 LOX load complete.
So with that call out, liquid oxygen loading is complete on the first stage. We'll hear a similar call out on the second stage. Now, our goal with these missions is to provide small satellite operators competitive pricing, increased flight opportunities, and flexibility. We're flying some really cool payloads on this mission, including spacecraft design to help monitor weather and environmental changes, as well as greenhouse gas emissions, spacecraft that improve communications for the Internet of Things, and those that also help measure and investigate galactic cosmic rays and solar rays. It's incredible how even the smallest satellites can make a meaningful contribution to the care of planet Earth and our efforts to visit other worlds. We are looking forward to providing a great ride to the 114 payloads on board today, just about 2 minutes from now. Next major milestone will be a call out for second stage LOX load complete. Once we hear that, we will be fully loaded on propellant for the launch attempt in about 2 minutes.
Stage 2 LOX load is complete.
So with that, we are fully loaded with about 1 million pounds of propellant on the vehicle. You'll see some clouds coming out from the vehicle. There they go. These clouds are coming from the transporter erector lines. The transporter erector provides the propellants to the vehicle. We're just clearing out the lines and the cold oxygen that is in those lines ends up coming into contact with the moist Florida air and produces literal clouds around the vehicle. Coming up, next major milestone will be Falcon 9's transition into startup. That means that the flight computers on board the first and second stage will have taken over the launch countdown, and they'll continue to have control of the vehicle through the rest of the mission. Next major milestone will be the launch director giving their final go for launch.
Go for launch.
And with that call, all systems go for launch. Let's watch as this Falcon 9 takes the Transporter-6 mission to orbit.
T-minus 30 seconds. T-minus 15. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And liftoff.
Difficult pitch down range.
Stage 1 chamber pressure is not open.
We're just about 40 seconds into flight. Falcon 9 clearing the tower at Space Launch Complex 40 and making its way to orbit. We are currently throttling down the Merlin 1D engines on the first stage in preparation for the point of max Q. That's the point of maximum aerodynamic pressure.
Falcon 9 is supersonic.
Maximum aerodynamic pressure is the point when the highest stresses are experienced by the vehicle during the ascent.
Max Q.
With that, we are through the highest stresses on the vehicle. Coming up, we've got several events back to back. The first of those is main engine cutoff, or MECO. There will shut down the 9 Merlin 1D engines in preparation for stage separation. Stage separation is where pneumatic pushers will separate the first and second stages. And then we'll have second engine start number 1. We just heard a call out for MVAC chill-in, so we've begun chilling in the turbopumps in preparation to start the Merlin vacuum engine on the second stage. While the second stage engine is burning, the first stage will be performing a flip maneuver, and then it will do a boost back burn. That boost back burn will ignite 3 of the Merlin 1D engines to make the first stage's way back towards land, since we are attempting a land landing today with this first stage. So again, those events back to back, MECO, stage separation, first stage flip, second engine start number 1, and then the boost back burn.
Stage 1 shutdown.
Stage separation confirmed.
MVAC ignition.
Stage 1 boost back startup.
So there is those 5 events. Awesome shots from the ground. You can see the first stage boosting away. That was on the left part of your screen, and the second stage continuing to burn. Now this burn on the first stage will last about 47 seconds. And the second stage is going to continue burning for a while. It will complete its burn until the T+8 minutes and 20 or so second mark. Shortly after the boostback burn ends, the next major milestone will be fairing separation. You'll see that on the right-hand side of your screen.
Stage 1 boostback shutdown.
So there is successful shutdown of the boostback burn. You're seeing some pulses there from the ground from our attitude control system. We use nitrogen gas as our attitude control medium, and it helps us keep pointed in the correct direction. Here you can see the bursts firing on the first stage on the left-hand side of your screen, as we are also deploying our grid
Fairing
fins.
separation confirmed.
On the right-hand side of your screen, you just saw fairing separation. We may get a view of those fairing halves. In fact, you can see it on the right-hand side of your screen, just behind the Merlin vacuum. Heading back to planet Earth, we will be attempting to recover both of these fairing halves once they land back in the water on a recovery vessel named Bob. Now, if you're just joining us, welcome. We're about 4.5 minutes into today's mission. We're in the first of 2 Merlin vacuum burns. First burn will last until about the T+8 minute and 20-second mark. Next major milestone will be the first stage's entry burn. First stage is on the left-hand side of your screen. And we're now looking at a view down the body of the first stage, past 2 of the grid fins back at planet Earth. Now we execute the entry burn in order to slow down the first stage before hitting the densest parts of the Earth's atmosphere.
Vehicles are on a nominal trajectory.
Without that burn, we'd be only using the atmosphere to slow down the Falcon 9, and that puts a lot of extra stresses on the rocket. So we ignite 3 of those Merlin 1D engines to slow down as we hit the thickest parts of the Earth's atmosphere. We had an on-time liftoff, 9:56 a.m. Eastern Time from Cape Canaveral Space Force Station. And we're carrying the Transporter-6 mission on the second stage right now. It's SpaceX's 6th dedicated small-sat rideshare program and our first mission of 2023. We're targeting at least 3 dedicated rideshare flights to sun-synchronous orbit per year. We also offer opportunities to ride to orbit on our Starlink missions, which launch about once a week. Now, these small sats can ride to space on our Falcon 9, Falcon Heavy, and the Starship vehicle in the not-too-distant future. You can see that the grid fins have deployed on the first stage. We've got 4 of these hypersonic grid fins near the top of the stage. And once we get into the thicker parts of the atmosphere, it's only the grid fins that do the steering. To make our way back to landing zone 1, you can actually see the Space Coast of Florida there on the left-hand side of the screen. Next major event coming up in about 15 seconds. That's the first stage's entry burn, but will ignite 3 of the Merlin 1D engines.
Stage 2 FTS has safed.
Now keep an eye on the speed of the first stage in the lower left corner of your screen. You'll see that
Stage 1 entry burn startup.
drop off dramatically as the entry burn is slowing us down. Pretty quick burn. This one will last about 20 or so seconds.
Nominal trajectory.
Stage 1 entry burn shutdown.
And there is successful shutdown of those Merlin engines. Now, as we are slowing down, re-entering the Earth's atmosphere, if you're in the Florida area, you may hear some sonic booms.
Stage 1 FTS has safed.
We are attempting to recover this booster for the 15th time today, targeting this landing at landing zone 1. We've got just one more burn, which is the landing burn on the first stage. We'll ignite just a single center Merlin engine. That'll happen just before touchdown.
Stage 1 transonic.
On the right-hand side of your screen, we've got a ground view of stage 1. You can see the center engine
Stage
has
1 landing
ignited.
burn.
we'll expect to see the 4
Stage
landing
2
legs
terminal
deployed
guidance.
for a soft touchdown at landing zone 1. Now, during this, we'll also hear a call out of second engine cutoff on the second stage.
Stage 1 landing leg deploy.
Seco.
Stage 1 landing confirmed.
So landing is complete. We also heard a call out there for Seco.
Nominal parking orbit.
Seco is second engine cutoff number 1. We just heard a call out as well for nominal parking orbit. And with that, we have landed the Falcon 9. It's our 161st landing of an orbital class rocket. This booster's 15th. Now coming up, our next major event will be in about 45 minutes. That is for second engine start number 2. And that'll be followed shortly by payload deploy of the first 35 payload deployment events. So we're going to leave you with views from space, and we'll see you back shortly for second engine start number 2.
Expected loss of signal, Cape.
Acquisition of signal, reef.
We sat there, 25th century AD. We sat there and looked at the rockets from Mars, and you just boggled the mind. The technology caught up, didn't it?
Acquisition of signal, Maldives.
Welcome back to our coverage of the Transporter-6 mission. We've had a great mission so far. We lifted off on time at 9:56 a.m. Eastern, recovered our first stage at landing zone 1, and completed the first of 2 second stage burns. Now we're coming up about 20 seconds away from a quick reignition of our Merlin vacuum engine. This burn will just be 2 seconds to circularize our orbit. So coming up, second engine start number 2. And there is successful startup, SES-2, as well as second engine cutoff number 2.
Nominal orbit insertion.
With that call out from mission control, we are in the expected orbit. As I just mentioned, you are watching the Transporter-6 mission. This is our 6th dedicated rideshare mission and SpaceX's first mission of 2023. The Falcon 9 lifted off at 9:56 a.m. Eastern Time from Cape Canaveral Space Force Station in Florida. We successfully separated the stages, landed that first stage at landing zone 1 for our 161st recovery of an orbital class rocket, and we just completed the second of our 2 planned second stage burns. If you're not familiar with our transporter missions, they are dedicated rideshare flights. SpaceX is targeting at least 3 sun-synchronous orbit missions per year, in addition to various opportunities for a ride on our Starlink missions, which launch about once a week. The small sats can ride to space on our Falcon 9, Falcon Heavy, and in the not too distant future, Starship. Now we've got 114 spacecraft, including CubeSats, PicoSats, Microsats, and orbital transfer vehicles carrying spacecraft to be deployed at a later time in the mission. And as I mentioned earlier in the webcast, we are flying some payloads that are really cool to help monitor weather, environmental changes, greenhouse gases, satellites that improve communication for the Internet of Things, and satellites that'll measure and investigate galactic cosmic rays and solar rays. Now, for the 114 spacecraft, there will be a total of 82 deployment events. Those will happen just past the T+58 minute mark, so just about a minute from now. And the payload deployments will last approximately 30 minutes. Now, unfortunately, we only have partial ground station coverage for the deployment sequence, and the ground stations are how we get our telemetry and these live views of the second stage. So we won't have coverage of all of the deployments visible today. But once we get ground station coverage back on the other side of that blackout, we'll expect to have telemetry and hear audio confirmation of the payload deploys that'll occur during that period. It's also worth mentioning that because these spacecraft are being deployed in groups in quick succession, We may not be able to confirm every deployment in real time. While you will hear most of the callouts by our mission control operators, we will try to provide updates for any that we don't hear real time by the end of the webcast. We do have a full list of the payloads on SpaceX.com if you'd like to follow along, but for now, we're going to listen in as the payload deployment sequence is about to begin.
EOS SAT-1, separation confirmed. EOS SAT-2, separation confirmed. Lemur 2, immaculate, separation confirmed. Lemur 2, Taha 01, separation confirmed. Connecta T1.2, separation confirmed. Gamma Alpha, separation confirmed. Bro 8, separation confirmed. Newt, separation confirmed. Huygens, separation confirmed. Lemur 2, disclaimer, separation confirmed. Starvibe, separation confirmed.
Lemur 2, Steve Albers, separation confirmed. ISI launch Cleos KSF-3A, separation confirmed. Birkeland, separation confirmed. Space B 156, 167, separation confirmed.
Expected loss of signal, reef.
Lemur 2 M Molo, separation confirmed. ISI launch Cleos KSF-3B, separation confirmed. ISI launch Cleos KSF-3C, separation confirmed. Lemur 2 Falari, separation confirmed. ISI launch Cleos KSF-3D, separation confirmed. Flock 4Y, separation confirmed.
Qualities. Expected loss of signal.
Space BD ISI launch Poly 10 from Kiev, separation confirmed. Flock 4Y, separation confirmed. Guardian Alpha, separation confirmed. Flock 4Y, separation confirmed. Flock 4Y, separation confirmed. Space BD Sony Sphere 1, separation confirmed. ISI launch Clyde Space NSL SAT-2, separation confirmed. ISI launch Sternula 1, separation confirmed. Flock 4Y, separation confirmed. Flock 4Y, separation confirmed. Flock 4Y, separation confirmed. Block 4Y, separation confirmed.
Now, at this time, we've had confirmation of 33 out of the 35 deployments, but because the spacecraft on this mission are small sats, it can be sometimes difficult for us to confirm the deployments in real time. So we're going to confirm with our teams and provide an update a bit later on in the broadcast. Now, I mentioned it earlier, but we are entering into a telemetry blackout period. During this time, we're expecting to deploy an additional 20 payloads. This loss of signal will last until about the T+1 hour and 16-minute mark, so we'll be back just before then to get confirmation of the payload deployments that occur during the telemetry outage, as well as we'll be standing by for those final 27 deployments while we have telemetry back. For now, we're going to leave you with some space tunes, and we'll see you back around T+1 hour and 15 minutes.
Expected loss of signal, Bangalore.
Welcome back to our webcast coverage for the Transporter-6 mission, SpaceX's 6th dedicated small sat rideshare program. Now, we've had a successful liftoff at 9:56 a.m. Eastern Time from Space Launch Complex 40 in Florida. And so far, we've had 33 confirmed separation events. We're currently awaiting callouts for another 20, which occurred during a telemetry blackout where we didn't have access to ground station coverage. We're also getting ready for the final 27 spacecraft to deploy. For that full list of payloads we're flying today, head over to SpaceX.com. Also, really quickly, because these spacecraft are being deployed in groups in quick succession, we may not be able to confirm every deployment in real time, so we'll expect we may need a few extra minutes to confirm these final deployments. Let's listen in.
Acquisition of signals, forward.
Separation of 20 payloads confirmed. Flock 4Y, separation confirmed. Flock 4Y, separation confirmed. Flock 4Y, separation confirmed. Flock 4Y, separation confirmed. Block 4Y, separation confirmed. Block 4Y, separation confirmed.
Link Tower 3, separation confirmed. Albania 1, separation confirmed. Link Tower 4, separation confirmed. YAM 5, separation confirmed.
Acquisition of signal, Pogo.
NewSat 34, separation confirmed. Albania 2, separation confirmed. First ISI satellite, separation confirmed. Umbra, separation confirmed. Umbra, separation confirmed. SAT-35, separation confirmed. Ion SCV-007, Glorious Gratia, separation confirmed. Ion SCV-008, Pierce Franciscus, separation confirmed. Launcher, Orbiter SN1, Space Tug, separation confirmed. Second ISI satellite, separation confirmed. Skycraft, separation confirmed.
Expected loss of signal, small ward.
Figurehead 5, separation confirmed. Chimera Leo 1, separation confirmed.
Acquisition signal, boss.
Dragonfly Aerospace, EOS SAT-1, separation confirmed.
As you may have noticed, we were able to confirm 77 of the 82 deployments. Now, because the spacecraft on this mission are small sats and because some of them deploy in close proximity to another, it can be difficult for us to confirm the deployments in real time. I've heard from our teams that we likely won't be able to make confirmations in the next few minutes. So we're going to end our live broadcast here, but we'll provide an update on those final confirmations via our social media platforms as soon as we receive them. We want to thank you for watching today's launch, and we'll see you next time.
Well, there you have it, space fans. That's the end of SpaceX's Transporter-6 launch. Pretty amazing views that we got there at the end of those satellite deployments. It does sound like they've got some work to do to confirm some of those final satellite deployments. They said 77 of the 82 deployment actions for the 114 satellites were confirmed. I did hear a successful confirmation that the EOS SAT-1 satellite did deploy. So that's really great news for the EOSDA team that we spoke to earlier. And so they've got their job cut out for them now, making sure they can get contact with the spacecraft with their ground stations around the world and beginning that 6-month commissioning process that we heard them discuss earlier today. I want to thank you all for joining us today for this launch, the first launch of 2023. That was really exciting to see, and I was really just taken aback by the amazing video that we saw, not just of the launch itself, but all the way up through stage separation, the booster landing. This was the 200th flight of a SpaceX 200th mission for SpaceX 15th flight for this specific Falcon 9 booster, and the 161st landing for SpaceX as well. And like I mentioned earlier, they're off to a great start. What may be another record year for SpaceX. They launched 61 missions in 2022, 31 missions in 2021. They may exceed that this year with all of the flights they have lined up, but we'll have to wait and see. Other big things to watch from SpaceX this year include the testing going on in South Texas of their Starship mission, and they do have at least one, if not two, private missions for astronauts this year. The Polaris Dawn flight coming up, as well as with the billionaire Jared Isaacman and his private crew. And that will include the first private spacewalk in history. So lots of good things to look forward to. But in the meantime, it's a big congratulations to our friends at EOSDA for their successful EOS SAT-1 launch today. And thank you for tuning in, and keep looking up. We'll see you with the next launch.